I'll be fine. All right, so 3B.2 method, I call it X in box. I used to call it cabin box, but it just works better. It's called an X in box. For short, we're calling it X box, okay? So we're going to talk about the X box method. And for the X box method, you're going to have it represents the 4 steps to solve. So the 4 steps to solve is you're going to always check for GCF in your model. So in box 1, you're writing 4x squared minus 15x minus 4. And you're going to ask yourself, is there a GCF? Is there a GCF between these 3 terms? The answer would be no. So there's no GCF. So we're good to keep going. Next, identify your variables. Identifying your variables is identifying what's your A term, your B term, and your C term. Your A term is going to always be with the x squared. So x squared, we call our A term. Your single x, we call that our B term, and your constant is our C term. This is going to become important because you're not going to always be giving it in numerical order by power of variable. So currently right now, it's in the proper order. So we have x squared, x to the 1, no x, right? It decreases in power. So that's step 1. Check the GCF and identify your variables. In step 2, that's where our x comes into play. So you're going to draw an x in step 2. The x represents the numbers that you're trying to find. So first thing you're going to do is multiply your C term times your A term. Remember, our C term was -4, and our A term was 4x squared. So you're multiplying those two together. -4 times 4x squared is -16x squared. Your B term, well, our B term is the middle term, and our B term is -15x. Okay? To find the outside of your x, all you're doing is asking yourself, is what multiplies to give you the top of your x, but adds to give you the bottom of your x. So what 2 numbers will multiply to give me -16x squared, but add to give me -15x? Well, we know they both have to have an x because it has to be x squared, right? So when I think of 16, -16, I have +1 and -16. We have -1 and +16. Do I need to keep going or do we see which ones work? See which ones work. Okay. So if you have 1x and -16, well, 1x times -16x equals -16x squared. 1x minus 16x, or 1x plus -16x, equals -15x. Do we see those numbers? Okay. Now in box 3, in box 3 is your GCF box. Your GCF box comes from filling in things you already know. So in the first box is always your first term, which is your A term. And the last box is always your last term, which is your C term. And your diagonal boxes are your x's from the x. So the x values you found in your x. So plugging those in, my A term is 4x squared. My C term is -4. And it doesn't matter which x you put where. So I'm just going to put -16 here and +1 there. Once it's in the GCF box, all you're doing is finding the greatest common factor of every row and every column. So you're finding the greatest common factor of every row and every column. So in the first row, 4x and 1x, their GCF is just x, right? And the second row, the GCF is -4. Remember, if your leading is negative, then your GCF is negative. And the first column, our GCF is 4x. And in the last column, our GCF is 1. All right, I'll do it. Thank you. So your factors are what's on the outside. So I have 4x and a positive 1. I have x and a negative 4. So those are my binomial factors for 4x squared minus 15x minus 4. Okay? Last step is to check yourself using FOIL. FOIL just means to double distribute. Okay? So all you're doing is double distribution. So double distribution just means I should come back to the original. Does that make sense? So FOIL, first term times first term. So 4x times 4x is 4x squared. 4x times negative 4 is negative 4x. I don't know what I was about to write. I was about to write 16, not 4x. And y'all were just going to let me. See? Terrible people. Y'all just watch me walk into traffic. That's not cool, guys. And then 1 times x is 1x. And then 1 times negative 4 is negative 4. Does this come back to our original problem in box 1? It does. Negative 16 and plus 1 is going to make negative 15. So if your FOIL checks out and you get everything that you got in box 1, guess what that means? You're a genius. You did it correctly. All right. So on the next page, guess what you're going to do? Yes, it's your turn. Okay. It's your turn to go through the 4 steps of the box method. Time to play Xbox. Okay. So you have 5 plus 17x plus 6x squared. So to begin, you're going to write it in the correct order. So in your box 1, you have 6x squared plus 17x plus 5. So in your box 1, you put it in correct order. And now you're going to solve. All right. So I'm going to give you a couple minutes to go through and apply the box method. Check it with your neighbors to make sure you're on the right path. All right. So let's see how we did. So first thing you're supposed to check is for GCF. And there's no GCF. So we're going to make sure we identify what our terms are. So remember, your A term is always with your x squared. Your B term is always with single x. And C is your constant. It's always with no x. All right. So in your cap, you're going to do C times A. So 5 times 6x squared gives me 30x squared. My B term is 17x. So I'm asking myself what multiplies to give me C times A, but adds to give me B. So what numbers of 30, factors of 30 will do that? Well, that would be 15x and 2x. So my numbers that work are 15 and 2x. Then we go to the box. In the box, your first box is always your A term, your first term, which is 6x squared. Your last box is your last term, which is your C term, which is 5. Your diagonals are going to always be the x's that made it work. So the x's that made it work are 15x and 2x. It does not matter which box you put those in, okay? So now you're going to do GCF, greatest common factor across the box. Think of this like reverse, what is it called in biology? Punnett squares, okay? Right? We're filling in the outside instead of the inside. So here, 6x squared, 15x, that's going to give us 3x. 2x and 5 gives us 1. 6x squared and 2x gives us 2x. And 15x and 5 give us 3. 5. I didn't write that. I was staring at this like, what am I doing? It's like, that did not make. Okay. You double check yourself. 3x times 2x is 6x squared. 3x times 5 is 15x. 1 times 2x is 2x. And 1 times 5 is 5. That's how you could double check yourself. So your factors are the outside. 2x and a positive 5. 3x and a positive 1. If you're not confident, then you would check yourself by using FOIL. 2x times 3x gives us 6x squared. 2x times 1 gives us 2x. 5 times 3x gives us 15x. And 5 times 1 gives us 5. When you add these together, does it come out? Back to box 1. Yes, you're a genius. So your answer is correct. And this is how you factor. Okay. This method is really good if you are a visual learner because you see the numbers being broken down, you're able to put the numbers back together. What we're going to learn on page 109 is a less, I don't know, drawn out method. Okay. Questions about this method though? Nope. Okay. So on GB.2, we have method number 4. Ignore the fact that I wrote 2 halves. It just means halves. I didn't, 2 halves is 4. I don't know why I wrote 2 in front. You're gonna split it in halves. In halves, you either can, I would do it horizontally, but you can do it whichever way you want. So like, here's a little line page and then example, then we're gonna do the you do. Okay. However you want to do it, but we're going to do halves, not 2 halves. Yeah. Okay, so method number 4 is grouping. What I'm going to show you, you're not writing down. Okay, we're going to walk through it. Do not write down. I repeat again, do not write down. All right, this is our walkthrough. So this is the method that when I was in school, my teacher taught us. I never saw Xbox or CAB or any other fun way of doing this. So this is just pretty straightforward. You're going to write your you're going to write your polynomial in mathematical form, meaning that you're leading with your largest power, so x squared, then x to none. Then step 1 is still the same. Is there a greatest common factor? If there is one, then you're going to factor it out. So in this case, there is no greatest common factor, so I wrote there is not one. Step 2 is you're going to do a times c. Same thing as c times a, right? You're going to do a times c, except you're only using the numbers. So a times 5, a times 5 is 40, and your b is negative 14. So you're asking yourself, what combination of 40 will make negative 14? So here are your options. Looking at set options, I would then select which one makes negative 14. I would select this one, negative 4 and negative 10, right? From there in step 3, you're going to replace your middle term, your bx. You're going to replace it with those values, negative 4x and negative 10x. So it just goes back into the equation because together they still make negative 14. After you replace, you're then going to use what's called the grouping method. You're going to group your first 2 terms together and then group your second 2 terms together. No matter what you're doing, you're still going to have to find the GCF. So you're going to find the GCF of each one. So in the first group, my GCF is 4x. In the second group, my GCF is negative 5. You're going to factor out your GCF. Whatever is your common binomial is your first factor. So my common binomial is 2x minus 1. What is remaining after you factor out your common binomial? That's your second factor. Okay. And then step 5 is again to check yourself with FOIL and all should come back together. Okay. Now, what makes this method? You see now. What makes this method any different than Xbox is just that it's just straight numbers. There's no visual, there's no organization to it. Well, there's a pattern to it, but there's no graphic organizer being utilized to make it work. Does that make sense? But everything else, as far as the math, is the same. Okay. So we're going to go through what I like to call the OG method of factoring. Okay. So in your top half of your box, you're going to write 6x squared minus 6x minus 20, minus 2x minus 20. Okay. In step 1, this is where we identify the GCF. So step 1, you identify the GCF. Is there a GCF here? Between 6x squared, 2x, and 20. 2. So we have our GCF, and we're going to factor out the GCF. So this leads us to 2 factoring out, and I'm dividing everything by 2. So we're left with 3x squared minus 1x minus 10. Okay, step 2 is where you identify your A, your B, and your C, and you're going to find the factors of your A times your C. So our A equals 3, our B equals negative 1, and our C equals negative 10. Agree? Okay. From there, you have A times C. Well, A times C would be 3 times negative 10, which gives us negative 30. So what factors of negative 30 will add to give us negative 1? So when you think of the factors of negative 30, because you need a negative and a negative, that means that one has to be positive and one has to be negative. Agree? Otherwise, it wouldn't work. So out loud, 1 and 30 is obviously too big. We agree? Okay. So let's do 2 and 15. 2 and 15, will they add or subtract to make negative 1 in any combination? No. Up next is 3 and 10. Well, 3 and 10, add or subtract in any combination to make negative 1. Up next is 5 and 6. Will some combination of 5 and 6 add and subtract to make this work? Yes. Our factors that would work are what, though? What kind of 5 and 6? We would need a, switch it. We need a negative 1 in the output. There we go. Okay, so 5 and negative 6 would work. That's because 5 times negative 6 equals negative 30. And negative 6 plus 5 equals negative 1. So that's why it works. So step 3 is to replace this into your original equation. Remember, with your original equation, you had a GCF. That GCF stays there. So we now have 3x squared. Yes. Yeah. Oh, that's supposed to be a 6. I thought you would ignore the fact so I wouldn't have to erase it. I thought I was smooth with it, but I wasn't. Thank you for calling me out. All right, so we have 3x squared, but now we're replacing the middle with these, right? So it becomes 5x negative 6x minus 10. So the only thing that was replaced was where negative x used to be, it became positive 5x and negative 6x, which still equals what? Negative 1x, right? Step 4 is our grouping. When you're grouping, you're going to group the first two terms together. So 3x squared plus 5x are grouped together. Plus the next one, when there's a negative, they are grouped all in together. Okay. Once you're grouped, you're asking yourself, what is the GCF between these two numbers? These two terms? What's the GCF between these two terms? So what is the greatest common factor between 3x squared and 5x? 1x, right? Do we see that? So 1x. What is the greatest common factor between negative 6x and negative 10? What kind of 2? It's going to be a negative 2 because remember we said if your leading term is negative, then your GCF is negative. So when you factor these out, you're left with x times 3x plus 5. You factor off the negative 2, you're left with 3x plus 5. So your final answer is, if you had a GCF, what was our GCF? 2. What is your common binomial? 3x plus 5. When we factor that out, what are we left with? We're left with x minus 2. So your final answer is 2 times 3x plus 5 times x minus 2. Do not forget GCF. Okay? If you think you did something wrong, then you would go back through and FOIL. So I would have 2 and multiply. 3x squared times x gives me 3x squared. 3x times negative 2 gives me negative 6x. 5 times x gives me 5x. 5 times negative 2 gives me negative 10. Keep going. And this would give me, distribute the 2, 2, 2, 2, 2, 2. So you give me 6x squared minus 12x plus, that's not right. Yeah, they get that right. Plus 10x minus 20. And does that come back to my original problem in box 1? Well, step 1. Yes. Okay. Step 5 is totally optional because it's just you checking to see that you did it correct. Does that make sense? If you feel fairly confident at step 4, then you are done. Okay. So again, this is very similar process to Xbox. It's just whichever appeals to you the most. Okay. All right. So on the bottom, you're going to solve this one. So you have 2x squared plus 9x plus 4. You get to choose whether you want to practice it with grouping or you want to practice it with Xbox. The choice is yours. Okay. So whether you want to use grouping or Xbox, it's totally up to you. All right. So let's see how we did. So did anyone do traditional grouping or did you do Xbox? Any traditional groupers? No. Well, there was no GCF. Okay, so no GCF. So then you go to step 2 where you identify your A is 2, your B is 9, and your C is 4. So A times C equals 8. So you're asking what factors of 8 will add to give you 9. I feel like I gave y'all a fairly easy one, just saying. No pressure, right? So your numbers should have been 1 and 8. Okay, step 3 is to replace it into the original problem. So we have 2x squared plus 8x plus 1x plus 4. It doesn't matter the order that you write the 8 and the 1. The order of that does not matter, just like in the box, the order didn't matter, right? So now you're going to factor by grouping. So we have 2x squared plus 8x grouped together plus 1x plus 4 grouped together. Their greatest common factor between 2x squared and 8x is going to be 2x. The greatest common factor between 1x and 4 is going to be 1. So what you're left with is x and 4. What you're left with here is a 1, an x, and 4. So therefore, your common binomial is x and 4. When you factor that out, what you're left with is 2x and 1. So you should have, either way, ended up with x plus 4 times 2x plus 1. Remember, for multiplication, the order you write the factors do not matter because it's going to be the same. If you're not confident what your answer is, what should you do? FOIL. Questions here? No? Cool. All right.